Okay, this video is going to be about some questions regarding a problem with a Bally 8-ball with certain solenoids not working, certain lights not working. Now this is not a Bally 8-ball. This is a Bally Centaur. A few years later, but it's the architecture of the systems were the same for about 5 years, from about 77 to 83 or so. So if you know the troubleshooting for one, you know the troubleshooting for most of them. So the problem, we'll start with the lights. Some of the lights are working and some are not, but he starts off with, on the light issue, when I hit the red button, no lights flash. By the red button, meaning that there's a self-test button on the coin door, that when you hit, this is what's supposed to happen. Like right now we're in attract mode. Incidentally, 8-ball has no attract mode like this. Some of the first solid state games, at least the ones with the chimes on it like that, some lights will be on when the game is over, but you know, once you start the game, they do what they're supposed to, but there's no attract mode. No animation when the game is in the game over mode. So, but what should happen when you hit the red button inside the coin door once, you should get all of the lights flashing just like this. So he says, well, most of my lights, I've got a couple of lights out that I need to fix. So when he hits the red button, no lights flash. The next steps of the self-test appear normal. In other words, when you keep hitting the red button, you'll progress to the, you'll go next to the display test. It's going to test the numbers on the plasma displays, and then solenoid test, solenoids one by one, sound test, switch test. Now we're into the settings / bookkeeping. If you look at it, I'm just scrolling through to get to the end of it. So you keep hitting that button while it's so when he hits the red button, no lights flash. Next steps of the self-test appear normal. So that's an odd one. So that to me is saying one of two things. I will let him quit making noise. Okay. So that is saying that there's a problem with the game code in it, which we'll talk about here in just a second, or that there's a problem with the lamp driver board. So I've never seen that happen with the game program, because typically with these, actually this is an aftermarket MPU. This is what the MPU the MPU would look like that came with it, and the game ROMs are here. This one's vacant, but many times that's the case. Would be here, and here. So it could be a bad game ROM with that, but you know, there's what they call checksums on this. If there's some bad data on it, usually it won't boot. So you know, that would be one thing to, you know, maybe the EPROMs are bad, or the game data is bad on it you know, these you can get the new EPROMs burned, you know, ready to go, relatively inexpensive. But also the problem could be in the lamp driver board. Maybe this is working properly, sending the right things out to the lamp driver board, and maybe the problem is here. Well, if the game boots and you can play a game and most of the lights are doing exactly what they're supposed to be doing, then it's probably not this. You know, it's probably going back to the game board. That's kind of an odd problem, because if it goes past the lamp test and goes to the solenoid, well, we know the button's working, and the button's actually not even part of the switch matrix. It's a separate grounds and does a interrupt request. Anyway, it's not the same as the switch matrix, but it's working properly. So, you know, once again, when you start the game, do the lamps that do work seem to be working properly, or are they just stuck on? You know, or some of them just always lit? And so that's kind of important to know if the ones that do work, that are lit, are they supposed to be lit, or are they just always stuck on? So if they're just always stuck on and they're not changing, and the lamp driver board is the problem. But if they're doing what they're supposed to be doing and a few lights don't work, but everything else is working properly, then I would be suspicious of the game code that's in the EPROMs here. And like I said, you can get new game code, new chips for this. So that's where I would go with that one. Okay, so well, let's stay with the lights. All right, let's say you get that figured out, and then you've got certain lights that aren't working. Just like I did, I've got one light out here, one light out here, and you want to figure out why that's not working. Well, this is how I would do it. This is what you have is you have voltage, 6.3 volts going to every light all the time, and these connectors on the lamp driver board, these connect the two on the right and the bottom left one, which specifically J2, J3, J1. Those are all the outputs for the lamps. And actually, you one more question in here. If one of the lights is a problem, will it cause any of the others to not work? No. On these, every individual light is addressable, meaning that like it's not on a lamp matrix like Williams would have, or other games would have. So every one of them is controlled individually. So one lamp won't cause another one to go bad. So what do you do from there? All right. Well, what you want to do next is determine whether the problem is on the lamp driver board, or is the problem on the playfield, or in the connector. So what you can do is you can take your schematic. Of course, you don't even want to think about working on one of these games unless you have the schematic for it. Luckily, all of these schematics are readily available. So, all right. So your lamp driver board for your particular game, this is the one for 8-ball. Thank you, Cousin It. Let's see if we can get that where the light may drown that out. But anyway, you can see for every light. So let's say you have a particular light that isn't working. To make this easy on myself, I'm gonna do this in kind of reverse order. So all right, all right. So I'm got a problem. This isn't the right schematic. So let's say your 2-ball isn't working. What you can do is, with the game on, you can unplug all 3 of these connectors. The game's still running, you just don't see any lights on it. So like I said, you're providing the lamp driver board is providing a ground for the light. So what I've done here is I've taken just a little jumper, alligator clip on each side, taken a resistor, I'm only using the resistor for its for the leg on it. I'm just clipping onto the one of the legs on. I'm just using that so I can stick that into that. Well, so all these Bally games have a ground strap that should be going down inside the game and then connecting to this ground strap down here. So I want to clip to it. And you can clip to any metal part of this. All this is grounded. I'm going to go down here though. So this is now the ground. So I've got J1, and you can see silk screened onto the top of the lamp driver board, pin 1, pin 28, pin 1, pin 28. So we're going to go pin 1 here, stick it in it. Now, of course, I picked one. I don't know if that's going to show up on the camera. That's a little. Let me see if I can just find a different one that's higher up on the play field. But basically, is you can, I think that might show up. So if I had, here we go. Here, I'm going to point the camera down a little bit more. Alright, so let's say the problem I was having was with this 10,000 point captive ball bonus advance. And I determined that it's pin, whatever this is, 24 on J1. I look at my schematic and it comes out to this pin. So I'm basically just grounding this wire, and as soon as I ground it, oh look, it turns on. That particular light turns on. Well, what that means is that everything from here down to the play field is good. That means this connector is good. That means the wiring to here is good, the socket's good, the lamp is good, everything from here down is good. And if that doesn't work when you do your self-test, that means the problem is on the lamp driver board. So then, you know, if you would go to J4, pin 20, whatever, whichever one it is, follow it back and you'll see Q, whatever it ends up being, Q23, Q20, whatever it is. And it'll correspond to one of these. It looks like a transistor. It's actually an SCR, silicon controlled rectifier. Anyway, it's going to go to one of these two devices on here. Both of these are SCRs. This is actually, these two are almost the same thing. This is just a little bit of a beefier version. They made these so that if they need to control two lamps at the same time, if your in-lane lights both lit up at the same time, this one can handle a little bit more current. So, but they're both SCRs, and they have NTE equivalents, easy to get. So you would replace that part on it, and that's going to fix it. These are decoder chips that come from the MPU. Basically, the MPU tells it in binary what light is supposed to light up, and these decode that binary and break it out. These really are very reliable, very, very, very reliable. All I've ever had to replace are the individual. As if you had a whole bank of you know, if you had 16 or 12, I don't know how many total it controls, but you know, say 16 of them, you know, that are all out, and they all share that same chip. Yeah, you would have a bad chip, but you don't. Once again, you really don't see these go out. Now, these connectors, these are called headers. The male part of the connector, these can get kind of dirty, and so you know, of course you can use your, you know, I've used Scotch Brite to clean them, but you know, I don't, you know, that's kind of in a if that's not the way you really need to do. You really need to if they're dirty, replace them. And you can, well, how do I know if it's dirty? Well, you can kind of feel when you put them on. If I put the right connector on it here, you will kind of feel it as it, no, I was right the first time. You'll, it should go on smoothly. It might be kind of hard to push in, not too hard, but it'll slide on very smoothly. If it doesn't, then you've got, you know, dirty connectors, and that's only half of it. This side of it could be bad as well. Now these are a little bit tougher to deal with, because these are what they call IDC connectors, where you have to use a special tool to punch down the wire into it. If one of these goes, if I have a bad wire on one of these, I replace it with the other style, with the crimp style. And you know, just replace the whole connector. Just you know, it's easier down the road if you ever need to work on it. It's easier to repair it then. So if it's the board, you know, if you doing that function doesn't light up the particular light that you're testing, if that doesn't work, you know it's the board. Well, let's say you do that, you put the ground in it and it doesn't light up. So then you know it's from here down. Once again, if you know your connector is good, you also, you know, you can kind of wiggle it, and if the light's coming on, and once again, let's say that you're in the test mode for the lights. If the light starts flickering, you know you've got to, when you move it, you know you've got a bad connector. That's, you know, end of story. Replace the connector, replace the header, you know, do both ends of it, and you're done. So let's say it's not the connector, it doesn't light up when you ground it up here. So then the next thing, if you know, obviously check your bulb. I've made a of course you can do it by, there's many ways you could check your bulb. You could take your ohm meter and see if it's an open. So if you take your voltmeter and put it on ohms or continuity, either one, and put it across the bulb, it's almost a direct short. It's only a few ohms, so that'll let you know that the filament's still in place. I've made a little test rig with a little battery pack and a socket for your 555 lights and a socket for your bayonet style, like your 44s and 47s. So that's the simple thing to test is the lights. Now, then, if it's not the light, well, what else is it? Well, the socket. They sell abrasive little Marco sells these little abrasive cylinders that you can put in your lamp socket. You can bend them back on the back of the playfield. Put this in it and rub it in there, and it'll clean off the contacts. That's good. That's a good way to do it. The best way to do it is to replace the sockets. If you look down in there, you'll see a lot of these older sockets. As soon as you look in it, you'll see that it's corroded or dirty or whatever, and you can clean it, but these games are 30 years old or older. Just bite the bullet and replace the socket. It's going to take a fair amount longer to do, but it's going to be it's going to be right. So anyway, so that's kind of the troubleshooting for the lights. They're once again pretty simple setup on these games. There's really not much to the circuitry for the light. It's just going to be generally it's going to be short of a bulb that's bad, a bad socket, a bad header connector, or a bad SCR. It's it's those are the common ones. So let's put my plugs back in. All right. So on the solenoids during the self-test, there is a thump on numbers 2, 4, 7, 8, 9, and 12 instead of 1 through 7. Also, the thump only comes for number 12. No other solenoids triggered during the self-test. Okay. All right. So I'm going to be kind of generic about this. That wording was a little confusing. So we're just testing the solenoids are pretty simple. Of course, when he's talking about numbers in your manual, you will see for your solenoid self-test, it'll just, we can show it on right here. Okay, 3, 4, 5, 6, 7, 8, 9, etc., 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 etc. Okay, so now this is the one for 8-ball. I don't know if you can see that. Of course, you can print that out. So it's just going to go in order: 1, out-hole kicker; 2, knocker; 3, so do your math on it. Figure out, well, which one's not working. When it goes to number blah, and nothing happens, well, you maybe, and also you have 6, this solenoid driver board can handle 16 solenoids, really 20, but as far as the self-test go, it's only 16 of them. 4 of them are special solenoids that they can lock on it all the time. One of them's flipper relay, coin lockout relay, and the other ones are reserved for gates usually. But anyway, so you've got 6 but you only have 14 on 8-ball. Actually they include the coin lockout door. So they're only using 12 of them. 12 of the ones that you can turn on and off. So not every, yours may scroll through, you may see it say 15 and 16, but there's really not a solenoid associated with it. So figure out which solenoids are not working and say, okay, all right, well, I've printed out my schematic for the solenoid, and when I get to the left slingshot, okay, when it hits, let's just say it's the left slingshot. When it gets to number 11 on the self-test, nothing happens. Well, what's number 11? I look at my solenoid identification table. Left solenoid, number 11 is left, I'm sorry, not solenoid, slingshot. When it gets to number 11, left slingshot, it's not working. So what do I do then? Well, then I go to my schematic for the solenoid driver board and I look for left slingshot. Left slingshot. J5, pin 15. Now, once again, my, I didn't get all the way out of here. I don't necessarily need to be. Okay, it should be resetting now. So, my... Okay, are you done? Thank you. So mine are not going to match up, but so I go to left slingshot, J5 pin 15. Now I could go find J5, which is going to be probably this one, and J1, J2, this is going to be J5. And I could ground out that wire right there. Same principle as the lights. All the solenoids have power to them all the time. And the solenoid driver board is grounding the other terminal of it, all right? So as soon as you grounded it, it will trigger here. So, so you go to left slingshot, J5 pin 15. Well, that goes to Q10. Q10, Q is the letter associated with transistor. So I find Q10 on here, which is behind this little sticker. I can't really see there, Q10. Now, this isn't going to be the same for mine because it's a different game, but I can take my ground wire. I've taken my little resistor piece out of it, so it's just the alligator clip. And how about that? It actually is the left solenoid. Maybe they had a little bit of consistency on the thing. Oh, this is kind of important. Don't hold it to the tab. You don't want that solenoid to hold for more than just a few tenths of a second. You're going to touch it as quick as you can. But you're going to do that. So that's what that is telling you, is that the wiring from here down to the solenoid is good. So same as the light board, we have two scenarios. Let's say you hit that and that works. That is saying that part of the solenoid driver board is bad. Most likely the transistor itself. You can cross-reference that. Bally gives you the cross-reference to it. I don't remember what it comes out to, but I use a TIP 102, which is a NPN Darlington transistor. Same thing they use in a lot of games. But I replaced mine with TIP 102s. There's other circuitry associated with the solenoids, and sometimes if too large of a fuse has been put in for the 44 volt line, if someone puts too large a fuse, it can actually damage it can burn things up on the back side of it. So I want to kind of keep it simple here. Start with replacing the main, the driver transistor. It could be that supporting circuitry, you actually have a transistor upstream from it. Actually, in this case, it's these ICs right here. They look like any other ICs, but this is actually a pack of transistors that invert the signal so that when it's high coming in, it's low. I'm not going to get into that, but it's these are pretty reliable. So it's chances are 90% or higher chance that if it's on the solenoid driver board, the problem is the driver transistor itself. Once again, it could be other components of it, but it is most likely going to be here. But inspect the area. Look on the front, looks good. Flip it over. Look on the back. See if you've got a trace that's burned and cut into. Well, you're going to have it flipped over anyway because you can't replace it unless you do it. You unsolder it from the back side. Okay. So you touch it. You touch the tab of the associated transistor, and nothing happens with the solenoid. It doesn't. Well, do other ones work? If none of the other ones work, then you've blown. There's a slow blow fuse. I think it's a 1 amp fuse under the playfield that gives you power to all the solenoids. If the 44 volt line on the power supply is blown, if the main fuse is blown for that line, your MPU won't boot. So if it's booting into the game mode, your main supply 44 volt is fine, but it will, you know, check for a blown fuse up under the playfield. Okay, let's say a lot of the other solenoids work. You know, you can just kind of tap different ones and it's going to activate the other solenoids, but that one that you hit doesn't work. Well, that's saying that this is most likely good, the solenoid driver board, but something down here is bad. So then that's when you you know, just check the solenoid. Put your you know, put your meter. You can put your meter on ohms. Actually, before you check the resistance at the coil, whichever plug is associated with that solenoid, unplug it. That way, you're isolated. You're making it so that it's not connected to anything else. You're not, so in case that transistor is shorted, you're not going to see a short on it when it's really not there. So take your solenoid. You know, resistance of a solenoid coil, depending on what its intended use is going to be anywhere from, say, about 3 ohms up to 20 ohms. It could be even higher than that, but that's pretty normal normal resistance values of them. Also, they have a diode. Oh, I should have had a coil here handy to show. I have one inside for any reason. There's a diode across it. You want to make sure that that is pointing the correct direction. The positive lead for all the solenoids, that you can tell which one is the positive lead going to all. It's going to be the same color going to all of them. A lot of the times on these it's a brown wire. Don't count on that, but you can look at the solenoids and you'll see it daisy chain. You'll see you know, one color wire going to all the. You'll see coming in and out, in and out, in and out to all the solenoids. That's the positive side of it, and the negative side of it, well, it's going to match the wire color up here at your connector. So the banded side of the diode always goes to positive. What happens if you reverse that? Well, solenoid will usually work one time, then blow the fuse. It's allowing the purpose of that diode is to keep voltage from when the solenoid disengages, when the magnetic field collapses. It could send voltage back to here and damage these. So that's really, it's that diode. The sole purpose of that diode is to protect the driver transistors for it. Theoretically, you could take that diode off of it. It would work, oh, I don't know, maybe for an hour or so, and you'd have, I don't know how long, but it would eventually blow out these driver transistors for it. So, you know, at that point you probably have a bad coil if that's not working. And you can do the same test with the solenoid. You know, you can ground the solenoid. You can flip the playfield up and ground the solenoid and see if it's bad. If you can take your meter, measure what you know to be the positive side of it. You know, like I said, it should be around 44 volts, 42 to 46 volts. And then you're going to see the same volt when the solenoid is not active. You're going to actually see the same voltage on both sides of the solenoid because it's not terminating anywhere. So so you got to make sure you ground the right side. If you ground the positive side of it, well, you're just going to blow the fuse. Might make a little spark. You're going to blow the fuse, but you're not going to do any damage to it, other than to a fuse. So you can use that same thing to check the solenoid. So I think that was about it. Oh,